in-person setting, what we do, we're going to measure a dimension of a lab table. So the tabletop of the laboratory table. So it's a square shape, it's a rectangular shape geometry, which means 3D rectangle. It's going to be look like that. Only the top part of the table. Okay. Then it has a length, it has a width, and then it has a thickness, right? So all of those now I have to measure because I would like to understand how the error is happening for every measurement, which we generally call the measurement error. And then I'm going to repeat the measurement to minimize the measurement error for each measurement. If I repeat the measurement, I can then calculate the average of those dimensions. If I calculate the average, then I need to understand how the error is actually propagate when I'm doing that average calculation. Then I have to do the mean deviation for each average values. Okay, so that's the idea. That's part one. So technically, I would like to find the length, but I need to find the average, which means I'm going to do multiple measurement of the length, and then I'm going to divide by number of repetition. So this sign is sum, right? That's what it's talking about is sum, adding everything together. And then same for the width, I need to find the average, which is going to be, I'm going to repeat the measurement like few times and then divide by the number of repetition. Thickness also the same. Sum of thickness each divide by the number of repetition. Now, when I want to measure something, I need to have an instrument to measure that physical parameter. In this class, if you remember the first day, when we're talking about unit and dimensions, I mentioned that this class, we're going to be working only on 3 different type of physical parameters, right? So in terms of those physical parameters, what we're interested during this class going to be 3 types generally. So those 3 types are, we're going to measure some sort of length measurements in unit meters, and then we will measure some sort of mass measurement, most of the time unit kilogram, and the time measurement unit second. There are other units we don't need during this class. We need only those physical parameters. This lab is based on only some sort of length measurement, okay? So which means I need to find the apparatus to measure that. This object is very large. Since this object is much larger, I can do all the measurement by using just simply meter ruler, right? But next week experiment, you will see if I want to measure some very smaller length values, like the millimeter level or even less than 1 millimeter level, then the meter ruler is not good. We have to find a different instrument to do that. Okay, that's the plan for next experiment. So in this experiment, since the length values are much larger, meter ruler is good. When it comes to the instrument, then you have to identify a couple of things, right? So you have to first check what are the scales, or which mean what are the units given in the meter ruler in this particular case. What kind of a scale in the meter ruler? Anybody know or remember? If this is a real experiment, every group, usually we do the group labs, like 4-member group. If we have a lot of students, if we have like 15 or so students, maybe like still 4-member group, we can go like each group has maybe 3 or less students. That's generally the plan. So when every student, in this particular case, every student can get a meter ruler. So if you get a item, not always every student getting an item. Some items are per group, but in this case, every student can get a meter ruler. So if you get a meter ruler, you check or you observe generally what it has in terms of unit, right? This generally meter ruler has
Centimeter?
good. Yeah, go ahead.
Is it centimeters?
Yeah, this has a centimeter, millimeter in one side, right? Centimeter, millimeter scale, and one side it also will show you inches, right? So the inches are not our SI unit, so we don't care it or we're not going to use it. Centimeter, millimeter side, you will see like larger line like this ones. right here. If you have a meter ruler in your table, a small one, you can take a look. And this large line start from the 0, then 1, 2, 3, 4, and then go all the way to 100, right? Because 100 centimeters is equal 1 meter. We generally going to use large meter, really 1 meter long meter ruler in lab class setting, okay? Now, each centimeter, if you look carefully, is subdivided into 10 segments. So, which means each centimeter is subdivided into 10. Each of those is actually 1 millimeter. So we briefly talk about those things during our first lesson, very end of that lesson. If I have apparatus, then I need to identify one important parameter that we generally call the least count. So the least count means what is the smallest possible quantity, your unit you can measure by that instrument. What is the least count of this instrument now?
Millimeters.
1 millimeter, right? So in this case, I can measure down to 1 millimeter. Whatever you can directly measure, that's actually the least count, right? So then if I'm measuring something, now let's say I have a meter ruler here, meter ruler has centimeter, millimeter lines, right? So each centimeter subdivide into 10 segments. If I zoom that in, let's consider this is a 1 centimeter line, 0 to 1 centimeter segment. And then this is subdivided into small sections, 10 of them, right? If I measure something sometime, let's consider I'm measuring this small length, few millimeters. Starting from here, I'm going to align this edge, and the other edge is can be exactly aligned with the millimeter line precisely. Then you can measure exactly to that millimeter. However, sometime if I align this might not be aligned exactly with the millimeter line. It might be in between, which means visibly you can actually observe or measure in between the 1 millimeter level, which means I can actually measure this measurement down to half a millimeter level, right? So that is what we generally call the uncertainty. Uncertainty means how much error you can have during the measurement. If you do one measurement, what type of error you can get in this instrument. So the uncertainty we can figure out if I know or if I figure out the least count. Uncertainty is generally the least count divided by the 2, right? So in this particular case, delta of, let's say, L, this is about 0.5 millimeters, okay? So every single measurement which I do with the meter ruler has to reflect this. That's important, which means when you're writing your measured values, that's when you're tabulating first, that table should reflect that uncertainty on that measurement. Now, if you take a look your table, we're not going to measure this, right? So since we're doing virtual, if you're doing in-person class, you will be asked to measure this. Then in your group, everybody get a chance to do that real measurement, right? If you look at your table, you can see length values, width values, and the thickness values are given. These are real values actually, the table, lab table in our lab, physics lab. And then if you take a look all those numbers written in a specific way, all the way down to the second decimal place in unit of centimeters. There's a reason why we do that, right? One reason is whenever you tabulating anything, directly measuring something and then tabulating, we will reflect first the directly measurable unit. We're not going to convert into meters at that level. We will convert into meters only at the end after we finish the experiment. Our results only we calculating, okay? At the measurement level, you must give directly the unit what you observe from the instrument, because this report usually read by someone else. You making the report later in your life, third year, fourth year, and after you go to the career, you making the report someone else, right? You to your superior or other project managers. Then they should be able to understand everything by just reading the report, because they're not going to go and do the experiment or the project, right? So that's why there's a certain process we follow when we're tabulating and do the calculation, that process is important itself. So first table usually have the units what we directly measure, in this case centimeters. And if you look carefully, I have written down all the way to this this second decimal place, fifth significant figure. Reason, what that significant figure reflect? What do you think? What this guy reflecting?
Whether it's measured in between the millimeter lines or on the millimeter line.
Right. So that reflecting the uncertainty of the measurement, right? So that technically actually reflecting error of every single measurement. So that means I can't actually measure that. I can measure only down to here, right? So you can see the first decimal place has a different numbers, right? 5, 8, 7, 3, 6, 7, 6, 5, right? Different numbers. But if you look at the last decimal place, it always 0 and 5, because I can either estimate directly into a millimeter line or I can estimate in between the millimeter line. So which means this last significant figure, this guy, either should be 0 or 0.5. It can't be anything other than that, okay? Now, that's the idea. If you tabulate nicely the data, the way you measuring with all those information, then someone else reading can actually extract all the information. So you don't need to tell the person who read this, if that person is technically knowledgeable, then he know what actually you're reporting. You don't need to necessarily tell even the instrumental error. By looking at the data, he can understand. So that's how important those things, okay? Especially chemistry and physics, those error, chemistry actually even more important, because when they have a very, very small, like maybe fifth level of decimal difference, when you're doing the reaction or something, then it's going to produce completely different results than what it's supposed to be. So it's extremely important, those things. Okay, guys, any question? Okay, so that looks good. Since we're not measuring, we can save a lot of time that way. That's why we can finish all the analysis also during the class. This measurement gonna take a little bit of time, even though it's simple. You have to be really careful when you're doing, because meter ruler has to be well aligned with the edges, and if it is slightly tilted and then so on, you will get errors. And also we have to repeat the measurement. So at least 8 or so measurements. Usually we done 8 measurements. The reason, if it is a 4-member group, every student can take 2 measurements, 2 readings per each dimension. Okay, that's why. All right, and on the table, if you look at it carefully, usually has a topic for each column, and then you can see each column has these square brackets. So what those square brackets means, if you see this point and then throughout the semester square bracket in any column heading, which means you're supposed to add the units, okay? For this one, I add the unit, most of them, except these 3. We can add them later. But as we go into the next week and followed by week, you will not get a data set like this one, okay? So because this one data is provided, but starting from next week, we're going to measure the data. We're going to collect the data as we usually do in person class, but by using a simulator. Okay, because of that, only the empty tables will be given. So everything else you must complete. Okay, guys, any question? All right, then we'll start working on. Now we can do the averages, right? Because every dimension I have remeasuring that 8 times. If I remeasure 8 times, there's few reasons why we're remeasuring, right? If you look those numbers like the length values, you can see it's always 182 centimeters in centimeter level. But if you go down to the millimeter level, I have a lot of error, right? See that one number is 182.5, another number is 182.85. There's like 3 millimeter difference roughly. So that it's a fairly considerable error. And on the other hand, if you look this table, this table is actually giving you what are the expected values, which mean what is the general dimension of those tables. So the length is 182.50, but I'm not getting it. I got that exact number only once. Every other time, I'm getting a different answer down to the millimeter level. The reason is actually human error itself. So when we do a measurement like this one with the physical, like we call the analog type apparatus, there's no directly digitally measuring anything. I have to observe, I have to align the instrument and then so on. So there's a lot of human error. So while we repeat in the measurement, we can actually minimize such error. That's one other reason, okay? All right, so we'll do the average. Now in Excel, you're not supposed to use a calculator. Don't use it because am interested to see those Excel functions, okay? That's why the original Excel sheet, after we complete, you save it. When you download it, usually Excel file download into your download folder, right? You download it, open it, work through it. After complete, you save it, and that saved completed file you upload as it is into the submission link on the Moodle because I want to see the originally completed file, not PDF or anything. Okay, do not convert into anything. After you upload, it might show you like the formatting and things like that slightly not nice because it's in the Excel format. That's okay because I usually download it and then reopen it to see all the Excel functions. So don't worry about too much. Okay. All right. Any question? To start then, okay. So let's do the average. Now in Excel, what we're going to use Excel function, right? Some of you might be know, some of you might be new to the use of Excel function, but doesn't matter. Everybody can easily learn these things. Okay, nothing much. So in the Excel, if you want to use a function, only thing you need to know what is the name of that function, like a real name. In this case, average is the name of the function, right? So all I have to do every Excel function is start with the equal sign. When you put a equal sign into any Excel cell, then that Excel know that's a calculation. So Excel going to go into calculation mode automatically, do the calculation. Okay. Equal sign. Now I have to initiate the function. So I know the function is average, but I don't know how the function must be written. I'm going to type like first two letters. When you type the first two letters, you can see all the possible function going to show up automatically. All you have to do, pick the right one, what you want. If you bring the cursor into each of these, even the definition of the function will show up. So I need the average. Just double click. That's the average function. That's it. You don't need to spend time on writing down those things or memorizing anything. Okay? Or you don't need to use a reference or anything either. Actually, Excel has a help menu. You can really type anything. It will show you what to do in detail. Okay. And also there's a direct link to the videos on Microsoft Excel and then so on too. But this kind of work, we don't need anything. Equal, AV, select the average, then I highlight the data set, that's it. Then you tell what's the data set needed to be average, starting from cell number C10. You just one click on there, then click on the middle and then drag. Then you can highlight the data set, close bracket, hit enter. That will do the calculation automatically. Okay, question. That's it. Very simple. Then if you use a function now in this table, there are going to be many calculations we do. But when I putting those functions into the table, I don't need to like rewrite the same function again and again. You have to give here only the different type of function per table. Okay. Since I did the average for length, I'm going to do the same average for width equal AV average all the width values, then equal AV average for each thickness values. But I'm not going to write all of these three functions here below the table. I'm going to add only one of them because function wise it's exactly the same. Okay? So we'll add one of them. copy the function, go into the cell, highlight it, copy it, and then go into first line here, and then write the meaning of that function. This is how you do average of length, right? Average of length, and then paste the function itself. If you want, you can add all three. That's okay. But you must add at least one of them. Each different type of function must show up below the table. Okay, guys, question. Okay, so, and when you do a calculation later in the semester, uh, at first time, don't round it automatically into the right significant figure. We're gonna do that rounding later when we summarizing the result only. At first point, use non-rounded, which means all of these numbers I should keep more than 5 significant figures, particularly for length and width, right? Thickness down to 3 significant figures, which mean we will keep at least 1 or 2 more decimal places. So if you want to change now, this is automatically formatted. That's why you see this way. Otherwise, if you want to reformat any of the cell in the Excel, you click on the cell, go to the home menu bar on the very top, and then look at little bit middle top. Then you will see the area right here says number. Then if I want to increase the number of significant figures, you can see this is small right and left arrows. If you click the left arrow, I can increase the number of decimal places, which means increase in the significant figure of that number, right? So I'm going to keep at least one extra at this point. Later, I will round it into the right significant figures, okay? We'll keep one extra for each of these. We'll keep one extra for all of these, actually. Okay, looks good now. Any question?
Yes. Do you mind to make it one more time, just a sample of the average? I can reach that up. Please.
Oh, sure. You want to redo that, the function?
Yes, please. It's
Yeah.
something doing wrong.
Let's do this. This one, first one, you go into that cell right here, equal AB, then pick the right function, average, open brackets, then you highlight this data set, click on the first one, keep clicking from one finger, left hand finger on the touchpad, and then dragging from the right hand finger, then automatically will highlight. And then even you don't need to close the bracket, it will automatically fill. If you hit enter, it will do the calculation. Okay. Or you can write this function like this way if you want to, equal average, open bracket, C10 colon C17 close bracket. If you type that, then function will work nicely too, okay? All right, guys, any other
Perfect, thank you.
Ask any question, okay? I'm not, that's what I mean earlier, wanted to say earlier too, because I'm not trying to go through here myself and then asking you guys to refer the video later, because that is not the point of synchronous class, okay? So if that is the case, then I can do this easily asynchronously, because I can record it and then upload that into the Moodle, okay? So ask the question during the class, no matter what the question is, try to work during the class. Then actually your time you're using effectively, then you don't need to really waste a lot of time after the lab class at all, really, because we're going to complete every single calculation on every single class. So after the class, you have a complete data table. That's it. Then you're done with the data sheet, okay? All right, any question?
For the average, do you want us to increase the significant figures, or do you want to just keep us as the what is it, like for 5 significant figure places?
No, use one extra.
Got it. Thanks.
Yeah. So in the first calculation, we always going to use like more significant figures without rounding, okay? That's the idea. Don't keep more, like you can see we can like go many significant figures like this, but don't do that either because that's not much meaningful. Use like if the required number of decimal places in this case 2, we'll keep 1 extra. That's enough. Okay, guys, everybody okay with that part? Any question? Okay, so I think these are fairly straightforward and simple. For most of you, I'm very concerned most of the time there are few students who doing this kind of work with the Excel for first time. If any of you like that, don't hesitate to ask the question, okay? Don't worry about others in the class. Maybe there is your friend who know everything to do with the Excel. So I'm not concerned about that student because he's fine. He's gonna do anyway because he know. But I'm concerned about whoever don't know the Excel. So if you don't ask the question, then I don't know who need the help. Then that's not gonna be a effective way of learning from your side, okay? So ask any simple question. How you did that? Can you show me again? Can you repeat that step? That's totally fine. That's what is learning about, okay? You finish the Excel file, then after we finish the Excel file, you have the Excel file. So you that whole Excel file, you submit back into the module page individually. And when you're doing the report, then you can use everything from your Excel file to the report data section directly. Okay. Got it? Yeah. Every one of you individually must do the data table. That's correct. Yeah. Yeah, if it is a group lab report that I did not address actually today, because there's two type of lab reports, right? One is actually, if you go here, you will see there's two type of lab report. One say individual, one say group. So most of the work, this lab actually individual, okay? You do individually all the data sheet anyway. And these three lab reports are also individual. But when it comes to the group, still you have to do the data sheet individually. But when it comes to the group, you can combine like 4 members work together to write a one report. Okay. Yeah, that's correct. Because usually making the report takes a lot of time. That's why you have option to do a 3 group reports too now. Okay. So that will hopefully minimize the time, but it's depending on your group. Okay. Sometimes we got really nice, hardworking people. Sometimes you might get a person or two who don't like to do a group work. So let's talk about that when it comes to the group report. So don't need to worry about right now. Okay, guys, so that's good now. So the average is fine. So then we'll moving on now into the next. Now, if I do average, now you know the error for each measurement is actually the error written in this table, right? You see this is small table right here that has the error for each measurement. Now, if I have a multiple measurement, if I do any arithmetic with the measurement, then the error is no longer the same as that individual measured errors for each measurement. So I have to find the error, what we generally call the statistical error analysis method. So we're not going to do the whole statistics class here. Okay, if you taken the statistic class, the already taken or the will be taking, then you will go over these things. So this is statistical error analysis very in detail. How to prove those equation, things like that. We are not interested in anything those. We are interested how to use those information to actually find the error associated with our calculation. Okay. Now this is very simple. I did the average, so which means I have now L average. I would like to find the error for L average, which means usually if I have a one length measurement, that measurement has positive or negative delta L. So parentheses unit of that. That's how the standard format look like for any given measurement, right? One measurement. But if I have the average right here, then that average doesn't have exactly this delta L error. That average is going to have a different error. We usually write this letter. This letter is actually small delta, Greek letter. This one is actually uppercase delta. If I usually write the uppercase delta, which means usually for the measurement error, this is actually for the measurement error. If I use a smaller delta, that is actually some sort of calculated error. Okay. So that is two types. If I do any arithmetic, I have to do the error calculation too. Okay? That's the idea of propagation of errors. Error is propagate when you do more and more calculation with your data. So now let's take a look how to do this part, right? So that can be done two different ways. So the one method, this delta L bar, I can do by taking the difference between the average value and every single value, absolute sign, which means we consider only the different positive sign. And then if I add all of them together, this is addition sign, and then divide by the number of repetition, this is actually what we call the mean deviation. So which means I have a mean value or the average value. Deviation means what's the error of that. That's the idea, okay? So that's one way. This is actually a longer way. But there's a shorter way to do that too, because Excel has inbuilt function for most of these. So if I want to do mean deviation, Excel has actually a function for mean deviation. I can use that function directly. That's another way to do that. We will do the both right here, but as the semester progress, next lab and the following lab, we don't need to use the detailed way. This is the longer way. We can actually use the Excel function directly if it is needed, okay? Only like first 3 labs also, we more focus with this error analysis. Later in the semester, we're not going to do error analysis always. The reason the lab itself can become very longer. So we don't have time to do the error analysis at all. Okay. So we're going to cut down the error analysis maybe after third or fourth lab, much into very, very low level. And then we focus into the lab itself. Okay. So we'll do that now, which means I can do L bar minus L here. Unit going to be centimeters. Make sure if you see a square brackets, add the units, equal sign. I need the absolute value, ABS, open brackets. L bar is actually 182.613, 182.613. And minus each L value, don't type the number. For the average value, type the number, but for the each L value, just click on the cell C10 because of a reason. Okay, you will see in a bit. So I got a number. That's a calculated value again. And then I want to do the same calculation throughout that column right here, right? So I did once that calculation. Here I want to do the same downward, same type of calculation, always average minus the L. So I go back to the same cell, click on there, you see a green color line around it, then a small green dot, right hand side bottom corner. Bring the cursor on top of that, cursor sign will change it to like solid black positive sign, click and then drag down. It will do the calculation automatically. So that's why the Excel is very easy to work with, because if you want to do those with your calculator, then you have to do this every single calculation by putting the numbers. A lot of error can happen during that number inserting, and also the time wise, it's going to take a lot of time. Okay. That's it. That is that simple. We'll add that function also here. That is actually, we can say average minus the measurement, for example, average minus length. I'm going to add only for that, right? So let's say average minus L parentheses average minus the length itself. Then we'll add the function into here. Okay. So some sort of physical explanation what that function do. You can type a sentence, or you can type some sort of mathematical way with the words. Whoever reads needed to be understand that and the function itself. Okay. Then any question so far?
Professor,
Yeah, what's up?
Can you show me the formula for the ABS?
Oh yeah, so the function for that is just equal ABS open brackets, and I put the average value, that number which I had earlier, 182.613 for the length. Then minus for the each length, I click on the cell name, that is C10 I'm starting with, because then I can click and drag, it will automatically the cell name by keeping the average constant. Then I can easily find the values for this column. Okay, that's why.
Okay, thank you.
Okay, guys, any other question? There's a lot of other way to do this Excel calculation, things like that. There is one way I'm using. You might know other methods to work with these things. That's totally fine if you know any particular way, but make sure you show the work here. Okay. Most of the functions, there are now two options. For absolute value, there's one function. Average, there's one function, and then so on. Okay, now what we can do, we can find the mean deviation, which means this cell should be empty. This cell, I'm not going to do anything because I'm going to take the average of this difference, then that is actually the mean deviation, equal average of that column is actually mean deviation, okay? I'm keeping one extra significant figure, because I can go down to only 2 decimal places. I can keep 3 decimal places here. When I do any error calculation, remember this very carefully. When I do error calculation, error does not reflect the significant figure. What it reflecting, error of each measurement. You can see error of each measurement go down to 2 decimal places. Any calculated error is actually only reflecting that amount, not the total significant figures on the number. Okay, that's important, which means in my error calculation, I don't care number of significant figure in the number. What I care, number of decimal places. That's all. We'll keep 1 decimal place more. Okay, any question, guys? We'll add that function also here. That's a different function. This is going to be, then we can say mean deviation from LAVG. Mean deviation, you can say like method 1, for example, that also fine. Method 1. Okay, so now we'll try to find the mean deviation by using the easier way. Right here in the cell number C19, equal, earlier I mentioned there's inbuilt function, right? So mean deviation is connected to the average. I don't know the function exactly. Because of that, I'm going to just type the average first to see whether, because this is a function connected, should be average, connected to the average. If you look at it carefully, that has the function there, the first function. If you take a look, AVEDEV, that's the average deviation that returns the average of the absolute deviation of the data points. That's what exactly means the mean deviation. So we'll use that average deviation, highlight the data set, only the data set, okay, without the average I calculated, hit enter. That will do the calculation for us. These two numbers exactly the same. So it doesn't matter which method we use, we can either do detailed way or simpler way, we will get the right answer. Okay. That's the advantage with the Excel. So we can say this is mean deviation, method 2. Okay, guys, question. All right, so then the same thing you have to do for the width and the thickness. Okay, so let's complete that. Let's do this for the width, centimeters, and then we need to get the equal ABS, open brackets, width average. I calculated 106.5. minus with first one, F number 10, close bracket, hit enter, then click and drag, and don't do any calculation on this cell, nothing to do there. Then do the average of that column. Then I will get the mean deviation for the width. Then we'll try that with the one single command equal AV average deviation, highlight the data set only for the width, hit enter. I'm getting exactly the same number, okay? Since the function is same, I'm not going to add those function here. But if you like, then you can add this function into here. That's okay, but it's not required, okay? Question? Okay, so then we'll do the same thing for the thickness, unit centimeters, and equal ABS, open brackets, thickness calculated average 2.469, minus first cell G10, enter, click and drag, and then nothing on this cell. I highlighted it because nothing to put there. You don't need to necessarily highlight. You can leave it empty, that's okay. But if you want, you can highlight with a like dark color, okay? Then we'll do the average, equal average of this column. And then we'll do that with the one single function equal mean average, average deviation. And then hit enter, I have the same answer, okay, bot method. And keep one or all of those automatically show up one decimal place. If not, make sure you know how to change the decimal places, right? I highlight all of these, change the decimal place with the home menu bar number part right here into one extra, okay? Question? Okay, so now that's good. So we almost completed the first table. So then there's two type of percent errors, which I mentioned, I think, during our first lesson. We did not do much there, but I mentioned that roughly. So this type of detailed error gonna take a lot of time. We're not gonna do this kind of detailed error analysis per measurement every lab. Okay, so we will do this maybe next two lab little bit more, but after that we're not gonna do this kind. But one kind of error analysis we're gonna do always, that is actually percent error. This kind. That important, because why it's important, most of the experiment we will be calculating something like known quantity to test it out our theory and principle. Because of that, after I calculated something known, then I need to make sure my answer is accurate enough. So that can be easily done by using the percentage error. There's two types of percent error. So the one we call PE, which means I'm comparing two numbers to the known value, which means known value minus the experimentally calculated value divided by the known, or sometimes it called standard value too, right? And then multiply by 100, then it is a percentage value. If that percent value is very small, then we know our experiment is actually very good. Our calculated value is very close to the expected value. If not, if that percentage error becomes much larger, usually up to about 5% acceptable in physics. In real life scenario, that kind of percentage error should be 1% or less to be acceptable actually. But in real experiment in our labs, there's a lot of human errors can happen. 5% is okay, but anything above that is actually very bad for experiment. But some experiment we can get up to 10% depending on how the student group actually collect the data, okay? So other type of percentage error we call the percentage difference, which means in such case, we have still the two numbers, but we're not gonna compare that to the known value. Instead, we're going to compare to the average between the numbers. So only the denominator is difference, okay? Nothing else. So that actually called the percentage difference. So these two gonna show up every single experiment starting from next week, okay? But other detailed work which we done for each measurement wise, we're not going to do more. We will do it maybe next experiment, one more, and then after that we're going to stop doing that because it's going to take a lot of time. Okay, guys, question. Okay, which mean in this particular case, if I want to compare, I need to know the known values. Known values are given in this table, right? So I have the expected value for length, expected value for width, expected value for thickness. We'll compare them. So percent error equal sign, open bracket, ABS, open another bracket, known value for the length, cell number K8 minus calculated average for the length, cell number C18, close bracket, divide by cell number C8, which is a normal, K8, close bracket, multiply by 100. So the percent errors, any errors, we not interested actually significant figure at all. Usually we're going to reflect only the error of the measurement, a significant figure relative to that. Okay, so which means the percentage error usually down to 2 significant figures. That's all. So this is a very small number, which means our measured value is actually very good. Each measurement has a different error associated with, but the average does not have actually a lot of error. Percentage wise, it's less than even 0.1 level. It's really, really accurate. That's the idea. Okay, guys, any question? Let's add that function here. It's going to be percentage error for length, but it is actually same for the other. I'm going to add only one of them, okay? Then you can do the same, nothing much to do here. There's nothing much to calculate for the mean deviation, okay? Which means these cells should be empty again. We can do the percentage error for the width and thickness because there's expected value, right? Equal open bracket ABS, open another bracket, width expected value K9 minus width average K18, close bracket, divide by K9, close bracket, multiply by 100. Very small again. We'll do for the thickness equal open bracket ABS, open brackets expected 1K10 minus calculated average, close bracket, divide by expected, close bracket, multiply by 100. That little bit larger because if you look at the two numbers, the difference is down to first decimal place. This is a small number, that's why the error is a little higher. But when the number is larger, first decimal place error, which actually not important. You can see that different by looking into the PE of length and width to the thickness. Thickness is a smaller number, first decimal place error, actually much bigger error. But the length is 182 centimeters. First decimal place is 1 millimeter error, so it's negligible. So that's why we do this percentage error. It's a very important observation to understand how much error is happened in our experiment, in particular measurement, okay? Question, guys. But it's still 1% is not bad relative to our normal lab errors. So anything less than 5, we expect it as a good. Anything less than like 1%, we consider really exceptionally good experiment. Okay. All right, let's see. Then the percentage difference. Again, these three cells going to be empty. Mean deviation has nothing to do with that comparison. So we'll compare these. And one more thing I forgot earlier. Now, if you look at the mean deviation values, right? 0.16, that number, nothing to do with the error of each measurement, right? If you look at the error of each measurement is about the 0.05. That is actually instrumental uncertainty, right? That's the idea of propagation of error. If I take the 8 measurement, do the error analysis for that one by using mean deviation, average deviation, then that number does not reflect the error of each measurement. That's a very different answer, okay? So that is two different things. Uncertainty for the instrument for each measurement. But what this is reflecting is actually what is happening is statistically when I did the error analysis by using 8 numbers, okay? That's the idea. That two we can't compare. There's no meaning. Okay, guys, question. Okay, let's do then percentage difference. So this is going to be equal open bracket ABS again, open bracket expected length, which is going to be on right here, cell number K8 minus cell number C18 close bracket divide by open double bracket, because denominator should be average. I have to put everything together in the denominator. Open double bracket K8 plus C18 close bracket divide by 2 close bracket twice multiplied by 100. Okay. So percentage error and percentage difference you can see very closer here. The reason actually numbers are the two numbers which we're comparing are very closer. That's why, okay. So this is actually PD for length. We're going to use one of them because it's going to be same function for the two. Question. Okay, so it looks good, I think. So I'm going to do the same calculation for other two, right? Equal open bracket ABS, open another bracket length width expected minus width average, close bracket divide by open double bracket K9 plus E18 close bracket divide by 2 close bracket twice multiplied by 100. Okay? About the same because two numbers are close by. Whether I divide by each number or at the average doesn't reflect much, okay? But it's not going to be the case for always, okay? So this can be two different numbers if the two numbers are actually much further away, deviating much. So that's why we need to check that depending on the question, the case-by-case basis, okay? Let's do that for the thickness equal open bracket ABS, open another bracket thickness expected minus thickness average, close bracket divide by open double bracket thickness expected plus thickness average, close bracket divide by 2, close double bracket multiply 100. About the same. You can see those two numbers are not exactly the same down to third decimal level. Reason, these two numbers are little bit much further away. Those are smaller numbers. First decimal place error means actually much. That's why you can see even PD and PE actually different from each other down to third decimal level. Okay? But these two, length and width, are very larger numbers. First decimal place error means just 1 millimeter or less. If I'm measuring 2 meters, error happening down to 1 millimeter means not big of a deal at all. That's the idea, okay? Any question? Okay, guys, so I think it looks good. This last line, you can keep it empty. These are the 6 important functions we must include. If there's a try space, just you can leave it as it is. We'll take a quick break and then we'll continue to the next few tables, okay? Okay, so let's move into the next table, table number 2. So that table, actually, we're going to summarize the result. Okay, earlier I mentioned that when we're doing the calculation here, we did not rounded everything properly, right? We keep like one significant figure extra, one decimal place extra. So we'll round this right here and they write it down in standard format. If you remember earlier in the beginning, I mentioned a couple of other things too. If I measure something, then we usually record it with the standard format. Standard format in generally measured value plus or minus what is the error, parentheses, and the units, right? Since I have done the average values, then I have to report average value plus or minus average error, which means the mean deviation, parentheses the centimeter unit, but centimeter unit is not the SI unit. When we're reporting at the end, I have to put everything into the right SI units too. So I can multiply this by 10 to the negative 2 and meters. So that's our standard format. Let's do that without rounding and with rounding, okay, in this table number 2. Now, when I want to like write something this way, this is like more mathematical formula, right? So in the Excel, you could write numbers like without doing mathematical formulas directly, like for example, for the average, which we got 182.613. You can write parentheses 182.613, then we can say plus or minus, and the error is 0.116, and then close brackets 10 to the power minus 2 centimeters. That's one way, right? Nothing wrong, but look not nice. That's the problem, right? So if you want to make it nice looking, anything you write like a mathematically nice looking, then you have to use the equation editor, right? So equation editor, you can click anywhere on the table and then click on the insert menu bar on the very top. Then it will open up a new window right here, new menu bar right here on the top. Then you look at very right hand side top corner. Then you will see a symbols. Then click the down arrow. Then it will give an option to equation editor. That's the equation editor. Just click on that. It will open a small like a square somewhere in the page. That's okay. You can click and drag that square anywhere you like. Bring the cursor onto the edge of the square and then drag it anywhere we like. I would need to keep it right here on the length, table number 2, second column. Then we write it down, the parentheses 182.613. And plus or minus, now if you look at the very top, equation editor function has actually those nice formatting, plus or minus. 0.116 is the calculated error, close bracket. Then I can use a script to make it 10 to the power value. 10 right here, negative 2 in the top, very nicely formatted, and then the unit meters, right? Right here, unit should be meters earlier to right in this one. You make it exactly to the middle of the cell because it's a square. I'm not going to go into any cell. I have to leave it, click and drag, and then move it to where I wanted to see that, okay? That's non-rounded answer in nice standard SI unit, nice formatting. Any question?
How did you get the plus or minus sign again?
That you have to take a look when you click on the equation editor, then on the very top, you will see equation at the very end. If you click that, then you will see all those functions. Plus and minus, all the Greek letters, script, division, and all of those. Found it?
Yeah, I found it. Thank you.
Okay, yeah. Okay, guys, any other question? Then that's it. That's simple. Table number 2, nothing much to do, just we rewriting. That's the idea which I mentioned earlier. When I doing the calculation first, I'm not going to round it, but we will round when we summarizing it. Usually this kind of information are go into like discussion section. If you're writing a lab report, okay? So in the discussion section, you have to explain what you've done, what you did in terms of calculation, what you accomplished, then you highlight everything nicely, what the results are, and then so on, okay? Insert text or insert equation? Angelica, what's your question? Insert text or insert equation? I think you're probably talking about insert equation. That's gonna be home, insert after the home to the right hand side. Then on that menu bar on the very top, last icon to the right top, symbols, down arrow click, then you will see equation. Okay, equation. Then when you click that, square will appear like this kind of box will appear anywhere. It says type equation here, then you click and drag wherever you wanted, okay. That's a nice way. So please try to do that. If you're doing it first time, don't worry about too much. It's going to be a little bit tough first 2 weeks. I mentioned that last week too. Work with the Excel, you might feel a little bit tough, but after you get practice, it's the same thing. We're going to be repeating with the different data set, right? Each time with the experiment, it's going to get much easier, okay, as the semester progresses. Okay, guys, so then we can round it into the right amount of significant figure. I'm going to copy and make a copy of that equation. If you want to make a copy, all you have to do, click on the equation, not in the middle, in the corner. You see that the cursor changes into like a larger positive sign with the arrows. When that sign click, then it's selected. Then you go click a copy, select anywhere on the page, and then paste it. Then you can make a copy of that same equation, because when I do in the second one, I don't need to write it down everything new. I just need to get rid of last decimal place. Make sure the rounding, right? Now I have to get rid of this decimal place in the error, that is 6, which means the next decimal place must round it into 2. Now, errors does not reflect significant figures. Significant figure is important only for the given number, what we calculated, main physical parameter, okay? 182.61 reflecting 5 sig figs because measured down to 5 sig fig. Error calculated this one, mean deviation, reflecting only 2 sig fig because accuracy is down to 2 decimal places. That's why. Question. Okay, good. No problem. Okay, guys. So then we'll continue. Let's do the other. So let's do the next one for the width. So that also I don't need to rewrite everything from the beginning. I'm going to make a copy of this equation, which I did earlier, and then drag it to the next cell, and then I will edit the numbers. That easier, right? So what's the width? 106.50. 106.50 and plus or minus Error is about 0.088. 0.088 and multiply by 10 to the negative 2 meters. That's good. Then make a copy of that, move it to here, get rid of 1 decimal place. Actually, we're going to write 500 to reflect 3 significant figures, right? Yeah, 3 decimal places. Good. And then let's cut down one of this here. Make sure the rounding that 10 to 0.09. Okay, guys. So that for the width. Question. Any question? Okay, then let's do the thickness. Same thing, I'm going to make a copy of previous equation, then I'm going to edit it. Okay, that is the easier way. What we have, 2.469 is the number we got. Delete this one. 2.469 plus or minus. Error we got 0.061. So error we got 0.061, and then we'll make a copy of that. And then edit it here, rounding, make sure this should round into 4.5, and then 1 should be disappear. Now it looks good. That is actually how we represent the data at the end, okay? So every experiment as we go on like that, this table right here may not be a table from next experiment because actually this is a result part. So that will be part of the discussion. So there will not be a data table particularly asking that. So you have to include those information into the discussion part, okay? All right, guys, question. Good. So then let's continue into next table. So anybody need any help, any question about that equation editor? Some of you might be doing it for the first time. Some of you may be okay with those, very familiar with those. Ask any question, okay? Any question? Let me check that question. Due to some reason, actually, I did not see that question earlier. Let's see that. If you want to download the Excel, easiest way is that you go into your my.bergen.edu. Inside that, actually, there's a link to download the Excel automatically. Okay, if you go into here, right here, in your lab folder, then you will see the steps. Okay, just log in into my.bergen.edu. Then click on the Office 365 download link. So that will allow you to download that. But if you are not using the download version of the Excel, if you're using the online Excel or particularly the Google spreadsheet, the format right here, what I showing, gonna be very different. So the function and everything which I show does not gonna exactly match or fit with the Google spreadsheet. Any of you using the Google spreadsheet, I would strongly suggest don't use it, download the Excel. We need that, then it is much easier for you to understand what I exactly talking about, because you have the exactly same Excel page on your computer, then it's much easier to follow, okay? Google does not have the exactly same picture, what I'm showing you. Any other question?
For the writing in standard format with rounding, why is it 4.5 for 0.45 for the thickness and not
Oh, sorry.
0.7? Okay.
No, that's very good. Thank you for pointing out. It should not be 0.45, it should be 4.7, right?
All right. Thank you.
Yeah. Thank you. Yeah. And just please point out those things, okay? Do not hesitate. So anybody can do mistakes, right? I can do a mistake sometimes. All right, guys, any question? Good? No other problems, issues? All right, so looks good. Then we'll move into next part. Now the next part, the table number 3, focus on detail, what we call the propagation of error analysis, right? So why the propagation of error analysis is so important? Now you have seen earlier, when I measure something, measurement has an error that is coming from the instrument, that is one number. But if I do an analysis, which means if I do a calculation like average or any other thing, the error associated with that number is very different than the error associated with the measurement itself. So that we call the propagation. Now, if I do a calculation, like in this case, what we're going to do, we're going to calculate the perimeter. Perimeter is around the table and the area and the volume, right? Just simple calculation, anybody can do that, right? But that number is not what we're really interested. What we're really interested is actually how the error propagate when we do any arithmetic. Now, there's two things you need to understand. You don't need to memorize any of those. Those equation, if it is needed in the formula sheet, you can use it. But you need to know if I do any arithmetic like a plus b, so a plus or minus b, actually one type of error analysis for that, what we call the addition or subtraction rule. These are coming from partial derivatives. You will learn this later, how to prove even this equation. Similar ones when you go into the higher level of calculus, but we are not interested proving anything here. So we interested basically how to use them to get the error what we needed. But we need to understand what to use precisely. That's all we need at this point, okay? So which means you don't need to worry about calculus at all. All we needed to know is how to use them effectively, okay? So which means I need to check first what I'm doing. So if I do the perimeter, perimeter is actually twice the length plus twice the width. So I can write 2 times the L bar plus W bar, right? Because we're using the average. Perimeter is automatically become the average too. So I'm going to follow the addition subtraction rule, which means the average error of the perimeter, which is the error, measured error of the L average, that means delta L bar, power 2 plus, then I have delta W bar, power 2 is square root of that. This is one way of doing this. And some textbook you will see without the power, this error can be right this way too, nothing wrong. You can see the error can be delta L bar plus delta W bar, nothing wrong technically. We will get exactly same, but in the statistical error analysis, we actually considering both plus and minus. That's why we have to square everything to get the positive and then do the error calculation accordingly. Okay, if I write this way, which means I'm considering only positive when I write in this equation, will not match with every single case. So that's why we're not going to use that. We're going to use a general version here, which is going to match with positive or negative, doesn't matter. It's going to be same equation. Okay, question. Even it's a negative number here, this sign doesn't change, okay? So that always a positive because I'm squaring both of them. Now, that's one rule we need to know. I need to check what arithmetic I do with my calculation. Accordingly, I'm going to pick. That's all. Then what's the other one is actually multiplication or division. So like for example, area, which is length bar times the width bar. So the area is average. I'm going to get length bar times the width bar. Now, this is connected what we generally call the fractional error, because when I use a partial derivative, I automatically going to end up with the fractional error. Because of that, my equation gonna be look like this. The square root of this delta L bar over L bar power 2 plus delta W bar over W bar power 2. So now if you look at it that, so what that actually showing us again, this equation right here is actually common even if I have here division. So which means, let's say I have a Z bar is equal L bar over W bar. This equation exactly the same. It's not going to change at all. One other thing is actually the fractional error. You remember that term probably from the lesson one. Fractional error means if I take the error of any measurement, divide by the measurement itself, that we call the fractional error. Usually, if I want to understand how accurate my measurement itself relative to the error, we're going to check that now. If I multiply this by 100, it is actually percentage fractional error. So we expecting this number to be very small, less than 1. Then our measurement is very accurate relative to its error itself. Okay. If this number becomes much larger, which means our measurement is actually very bad. Okay? So all of those physical meanings are the one what we're really interested at this point. Okay? Question, guys. All right, so that's about it. It's very simple now. It's not very big deal because we're going to use the Excel function, right? Don't use a calculator. You're going to write it down. These all the function. Okay, if you see this square bracket, which means I have to add the units, right? Centimeter here. We're going to keep the same unit at this point. Still we doing the calculation, even though this is a result, we will keep the same unit and then we'll do the rounding and the SI units later in our summarized result part. Okay. So let's write it down. Perimeter equal sign 2 multiply shift and number 8 and then length average cell number C18. I have to open the brackets right before that because length average plus the width average, right? So that will be the perimeter, twice the length plus twice the width. That's good, 578,225. That function I must collect down here. Let's say average perimeter or perimeter average, perimeter AVG. That's the function I use. If you look at the number, it has six significant figures, which means it has one significant figure already more than what it's supposed to be have. So we'll keep it like that. That's good enough. Do not show many sig figs than what is needed. 1 or 2 maximum than what is needed is enough. Okay. Very simple. So any question? Let's do next one then. Error for that one. You know the equation. I just need to multiply that. So equal sign. I need the square root, right? SQRT, open bracket for square root, then open another bracket for inner part that delta L, 2 multiplied by delta L. That should be the mean deviation for the length. That is C19, close bracket, power 2. Okay. Then plus open brackets 2 multiplied by width delta L, which means, sorry, delta W bar, mean deviation for the width, close brackets, power 2, close outer bracket for the square root, hit enter. That's it. Now that number you can see has a many sig figs, which we do not want to keep. Let's say this is delta for perimeter average, perimeter AVG. And that's a function. If you want to refer it, that's totally fine, equal and afterwards. Okay. Now, if you look at it, that number has a many significant figures, looks bad. So I need to cut down because the error does not reflect in significant figures. Error is actually comparing the error of the number itself. So which means I'm going to cut down everything down to 3 decimal places. Anything more than that, not much meaningful. Okay. All right, guys, question? Any question? Good, no problem. Okay, then we'll continue the same thing for the area. It's going to be then unit centimeter square, right? Because it's length times the width. Then the error also should be unit centimeter square. And let's do equal sign length average multiply by width average. Hit enter. Too many sig figs, no meaning. So we'll keep it 6 significant figures in totally. It's a large number, that's okay. I'm going to cut down all the numbers down to 1 decimal place. Then I have totally 6 significant figures. I can have only 5, okay? So let's copy that function, paste it here. This is going to be area average, area AVG. Let's do the error for that one. Any question, guys? Okay, so you can see how easy this is, right? So if you want to use a calculator to do this kind of function is actually very, very time consuming. And also I can have a lot of mistakes too, because when I put a number, this kind of small numbers into a calculator, many of them simultaneously at the same time making an equation, there's a lot of errors can happen, a lot of mistakes can happen. Okay? That's the idea of this kind of data analysis. So doesn't matter what field you're going to go in. Most of you engineering, definitely, I think. Most of you probably computer majors, but specifically if you are not, like chemistry major or any other general science major, you might think computation is not important, but it is not the case. You will surprise after you go into third year or fourth year. Okay, everything now is more focused on doing with the computer, not really by hand. That's why that's the main purpose I stopped using the calculator with the lab class a few years ago. Now we're not using that at all because it's not meaningful. Nothing, no skill you're going to develop with that. Okay. All right, guys. So in lab class, that one of the fundamental skill I'm focusing on, developing the skill which I can do all the data analysis with some sort of computational method. This is the foundation level, right? Excel, ground level. If you know Mathematica, MATLAB, little bit higher level. If you know how this can be done with the MATLAB very easily. And if you go another step, maybe Python, you can do every single this kind of thing just typing into the command line directly, right? So another higher level, and then so on. So it's going to be a good skill to develop anyway. So any question, guys? Okay, then let's continue. Let's do the function for the area. Equal sign, area calculated, D49 plus square root, SQRT, open brackets, open another bracket, fractional error for the length, which means the mean deviation for the length divided by the length average itself, close bracket, power 2, plus open bracket, mean deviation for the width divided by the width itself, close bracket, power 2, close bracket for the square root. That's it. Hit enter. Too many decimal places, and also you will now, by looking into that, you might feel like it's a large number. It's looked like large error because earlier I mentioned that error we expecting very small number, right? But that number is relative to the number you calculated. Your area you calculated in square centimeters, 19,448. So I'm getting 20 square centimeter error. So let's take a look whether our error is larger or smaller. If you want to do that, you take a look the fraction error, which means you take a look the error you calculated delta A bar divided by the A bar itself. If that number is larger, then it's not good. Equal sign delta A divided by the A itself, I'm getting very, very, very small number, 0.001. Multiply by 100, I get in 0.01 level of percentage error. So our calculation is very good, okay? So that's the manipulation of the data, right? That's what's happening everywhere now around us, right? So when I working on anything on the online, then there's a lot of ads, things like that coming in. All of those are data mining and data manipulation, right? So anybody can change the mindset of a person by just showing them a different angle. So by looking into this number, I feel like large error. But if I look this way, fractional error, then I can identify the real picture, right? So then I know it's a really smaller value. So I need to look at it in the different angle, case by case basis as we go on. Okay. Question? Too many decimals, right? So we'll cut down into like all the way to 1 decimal, because if I use in the square centimeter, number is written into 1 decimal. So my error should written into that decimal place. There's no meaning otherwise. Okay. Any question, guys? Let's collect that function into here. This is going to be then delta for area average. Okay, looks good. Let's do the volume. Centimeter cube, right? Because we multiply in 3 centimeter values together. Unit wise, I should get centimeter power 3. Let's do the volume itself. Equal sign length average from table 1 multiplied by width average from table 1 and the thickness average from table number 1. Now keep track how many significant figures in every parameter. Since I multiply now by the thickness has only 3 sig figs. So which means the volume should reflect only 3 sig figs. Anything more than that actually not much meaningful when I round it. Okay, hit enter. There's error message will pop up if you do any mistake on the equation. It's very easy to identify. Now, if you look at it, this number, that's much bigger number than even previous 48,012.8209. That .8209 actually has no meaning because I can go only down to 3 sig figs relative to that amount of 3 sig figs. Keeping the decimal in that number has no meaning. I already have 2 more. Okay? So I cut down all the decimals in the volume. Copy paste into here. This is going to be then volume average, or you can say average volume. Okay, then we'll do the error for that. Any question? Earlier I mentioned that the error equation for the 2-factor multiplication, but if I have a 3-factor multiplication, there's no different error equation, going to be the same, but the fractional error of all 3 factors should be included. That's all. If I have 4-factor multiplication, it's the same. Okay. So let's write it down here. Equal volume calculated, multiply SQRT, open brackets, open another bracket for the fractional error. Error for the length, divide by the length average, close bracket, power 2, plus open bracket. Error for the width, divide by the width average, close bracket, power 2, plus open another bracket. Error for the thickness, divide by the thickness average, close bracket, power 2, close bracket for square root, hit enter. Now that number again has too many decimals. I'm going to cut down all the decimal because decimals has no any meaning at all in this number. Now, if you look at the number, it looks very large, right? 1,186 errors. So what's that about? I need to take a look the fractional error to understand that. Delta V bar over V bar. Then only I can really get the feeling that whether this is a large error or not. Let's check it out. Delta V bar over V bar, which is 0.02. Even if I multiply by 100 for the percentage error, it's going to be 2% error, not bad at all. Okay, guys, question. It's going to be delta of volume average. Okay, any question? All right, so we basically, now you can get the feeling that how much easy the data analysis, okay? So data collection is the only important part. I have to be very careful with this data. If the data is accurately done, then the analysis part is so much easier. I can do like every single calculation within half an hour or less in this kind of experiment. Even later, we're going to do many different experiments with a lot of data collection, a lot of different analyses, but the calculation going to be so easy with the Excel page. Okay, don't use a calculator at all. All right, guys, question. Okay, let's do the last table. That means the summarizing result. If you need any help, you can ask. We have fairly decent amount of extra time. We can start the part of the next chapter in a bit, or we can talk anything about the vectors. If you want any help with the vectors, we can do maybe one quick example for the vector calculation, particularly for dot product and the cross product, because the next quiz from the vectors, okay, to get a better idea. All right, so let's summarize this again. I'm gonna insert the equation. What I'm gonna do, I'm gonna copy paste one of this function actually directly here. Then I'm gonna edit that much easier, okay? So perimeter, what I calculated 578.225. You can write from the beginning, but I bring the copy of previous equation. Okay, 578.225. And the calculated error is actually 0.290. That is non-rounded value, right? It's going to be 10 to the negative 2 meters. Let's make a copy of that, then we'll round it. Getting rid of one decimal place. This should be rounded into 3. This 0 should disappear. Looks good. Okay, question? All right, then let's do the area. So I'm going to make a copy of this guy and then edit that. So the area is square meters, okay? What's the number I got? 19.448.2. Let's take a look. How should I write that first? 19.448, 19.448.2 plus or minus 20.2 parentheses. This is actually centimeter square, right? That is not the right unit. I need to convert that into the right unit, 10 to the negative 4 meters square, because each centimeter is equal 10 to the minus 2 meters, okay? You take the square on both sides, this should be 10 to the negative 4. Now, if you look at inside is not in the correct scientific format. It's totally fine. You can keep it because it's not anything wrong. As far as you can reflect the nice way, the results, that's fine. But let's convert this into scientific format. When you're converting this into scientific format, we're not going to blindly follow the scientific format we discussed earlier, because when I reflecting errors, that blindly following the scientific format does not help. So I have to be careful now, because in error wise, I have only 2 numbers right here, right? when I doing the scientific format, what I'm going to do, I'm going to get rid of those two numbers, which means those two numbers I'm going to write 0.202. That 0.202 will reflect into the power positive 2. And this number also I can write the same way. If I write 194.482, then I can write 10 to the positive 2. Parentheses 10 to the negative 4 meters square. Then let's go one step further. 194.482 plus or minus 0.282 close brackets 10 to the positive 2, 10 to the negative 4 meters square. Let's simplify one step further. 194.482 plus or minus 0.282 close brackets. These two will simplify into 10 to the negative 2 meters square. Now, if you look at that number, that looks very nice. The reason I can read that error relative to the decimal places of the number. That's the idea of error. Okay, error generally the error we don't write as a big number because that should be a smaller number, right? Now the error is actually much meaningful. Earlier, if I have these two numbers, looked like the error is much big. I had to take a look actually the percentage error to understand that. But if I write this way, you can see I don't need to look the percentage error. That written line is actually reflecting this error is actually much smaller compared to the number itself. So nothing much to worry. So that's the idea. Okay. So we can't really blindly follow the sig-fig rules and the method sometimes we discuss in the lecture class. When it comes to the experiment, it's much different approach than what we discuss sometimes. The basic rules are must be obeyed, but the written things sometimes we have to just little bit tweak to reflect what we really like to reflect. Okay, question. All right, let's write it down this then. Let's write it down this way, right? So I'm gonna summarize this into 194.482, 194.482, and then the error is just simply .282. 282 and then 10 to the negative 2 is fine, but the meter should reflect meter square. I have to go to the equation editor window, script, power sign, then I should do meter to the power 2. Now it looks good. In right SI unit, number, when I look at it, it has a meaning, it shows the error correctly and then so on. Then you can do the rounding, okay? Correction, guys. Okay, good. Any question? All right, looks good, I think. Very quiet. All right, so let's continue into the volume. Again, the volume also I need to do this trick, right, which I did earlier because the numbers are too big. No meaning really writing that way. Let's write it down first, these two numbers. 48013 plus or minus 1186, close brackets. This is centimeter cube. Centimeter cube is 10 to the negative 6 meter cube. I have four numbers here. I'm going to write those four numbers like 1.186, which means if I write that way, 1.186, 10 to the power positive 3, plus or minus, this I can write 48.013, 10 to the power positive 3, close bracket, 10 to the negative 6 meter cube. Let's do a little bit of adjusting there. I have 48.013 plus or minus 1.186 close bracket 10 to the power 3, 10 to the power negative 6 meter cube. which means 48.013 plus or minus 1.186 close brackets 10 to the negative 3 meter cube. So that look nice because that reflect nicely. You can see the error is look nicely is actually matched with 3 decimal places again, right? So the number wise 48 and the error is 1 over 48. So it should not be much larger. That error, even that come to the first number level, the reason is actually error coming from the thickness that might be effective now. All right, guys, question. Let's do it here then. Make a copy of that equation, then edit it. That is the easiest way. I have 48.013 plus or minus 1.186. 1.186, 10 to the negative 3, and then meter to the power 3. Looks good. Then you round that by getting rid of last decimal place. Not only last decimal place, I think I should get rid of last 2 decimal places because I can go only down to 3 significant figures, not more than 3. So which means in terms of error wise, I can go down to first decimal place because the thickness, remember, measured down to 3 significant figures, okay? So I cannot reflect more than that, which means if I reflect 3 significant figures in my calculated value, then in terms of error, I can reflect only 1 decimal place. Okay. So all of those you can see. Now this calculation anybody can do, right? Grade 5 student can do this. If I ask him to measure with the meter ruler and then do the calculation, anybody can do this. That no need to be necessarily physics student. So the physics student means we interested to see more information that what we can visualize directly. That's the idea of the lab, all the labs in this class technically. Any lab, anybody can do, but in physics, we like to understand more detail, very fine detail inside those measurements. That major focus on almost every single experiment we do. Any question, guys? Good. All right, looks fine. We have like 15 more minutes. We can just do maybe very quickly review for the vectors maybe. Next 15 minutes. Okay, that's what we're going to usually do. If we get extra time starting from next week, I will use that for next chapter because when we go deeper into the semester, some chapters getting much longer. So we may have a lot of things to discuss. Since this is nothing much to do in last chapter, actually we will just quickly take a look one simple question for the vector. Okay, guys, any question? Anybody need any help on any of these tables? Okay, now every single lab class going to be like this, right? So we're going to do every single calculation. I strongly advise you not to watch. Instead of that, do it yourself. It's tough, I know, if you have only one monitor, one screen. I would strongly suggest either find an older screen or connected to your laptop. Then you have extra screen. Then you can open the WebEx on one screen and then do the Excel on the other screen, okay? Or maybe you can use two computers, or maybe the WebEx on one tablet or something like that, and the laptop for the Excel or something like that. I think you may need to adjust a little bit, okay? Those are not big deal if you little bit work around, but that doing this thing during the class is the more effective way, okay? Then you save this file. It's going to save it as you download. Don't change the file name or anything. Just save it as it is. Then re-upload into the LDS one. That's it. Then basically this week lab work done. You have nothing to do after the class, okay? So the time wise, you can minimize the amount of work very much in this way, okay? Question, guys.
For the part that you want us to include all the Excel functions and exclamation for table 1, do you want us to plug in every function for each situation, or do you just want us to put a general concept of the functions?
Different function one time, okay? That means if I use the same function again and again, you don't need to repeat them. Make sense?
Yeah, that makes a lot of sense.
Yeah. So any other question, guys? Okay, so most of the time the virtual class lab going to be more focused on data analysis, right? The one reason why I more interested that because you're not going to get physically measure the information what we usually do with the real setting. That's a disadvantage. I think that is a disadvantage because in physics and engineering, the physically measuring things is important. But in terms of what we measuring in this class, in a way, not super important because grade 5 student can measure that. If somebody explain, you measure this, you don't need to have a bachelor's degree to do that. Okay, anybody can do it. Like anybody who never done any physics. If I show the item and then ask him to measure this, anybody can do it. So don't worry about it too much by thinking about missing it. But what important is actually that detail what we go into. Okay, that's why every single experiment we're gonna go into very detail in terms of analysis. And in terms of measurements and things like that, I will give you more information as much as possible to